All right, good morning, guys. Super excited to be here to talk to you all about streaming. My name's Ray. I'm from the product team. And here with me, I have Indrajit. He's from the engineering team. And in case you can't tell who's who, Indrajit also put some very beautiful profile pictures on the slide, so you won't mistaken with that. It's awesome to see a crowd to come to the streaming talk. A quick brief on the agenda for today. So I started with a bit of an overview in terms of what's streaming, what's batch, because I think for Databricks, especially on the Spark and Structured Streaming engine, we have a very unique and expansive view of what streaming means for the platform. Then we'll talk a bit about the two different incremental processing engines that enables the different data engineering products at Databricks. And we'll talk a bit about these different product interfaces. Then Indrajit is gonna introduce some of the exciting innovations and new features we've released into these two different engines. And then finally, we'll have an exciting demo for you guys. So some basic stuff to begin with, streaming versus batch. Maybe before I get started, can I have a quick show of hands? How many of you guys today already use streaming in your data pipelines in production? So awesome, quite a lot of you guys. How many of you guys actually use streaming for operational, low latency, operational use cases like fraud detection, content recommendations? Also quite handful. We have some pretty amazing announcement for you guys today and also at the keynote. So it's a pretty savvy audience. So when I say what is streaming, then for sure, it won't be these things. So what if I say like these things? So we're probably getting close to what streaming is for you guys. But then really, if you think about these different technologies and products, what do they have in common? What does streaming really mean in the data space? So oftentimes what I hear people saying, they associate streaming with it's continuous, it's low latency. While all of these things are true, but actually, fundamentally, I want to talk about the fundamental semantics of stream processing and how we define streaming at Databricks. So at its core, the semantics of streaming is that it processes only new data from the source. And it's using a checkpointing mechanism to track what data has been processed from the source. And it only processes new data from the previous processing run. Now, follow that line of definition. So it's amazing to see actually the source of the streaming doesn't have to be a message bus system like Kinesis or Kafka or PubSub. You can also stream from cloud storage like S3 or Google Cloud Storage. Conceptually, you can keep loading new files as they land in the bucket. That's no different from continuously read messages from, say, Kafka topic. Now, the second interesting thing that's pretty unique to the structured streaming space is that you can actually run streaming processing semantics with triggered mode. It doesn't have to run 24/7. You can certainly run continuous, but it doesn't have to. If you sort of put time in slow motion for continuous stream processing, because it's stateful, it keeps tracks of what has been processed, you can actually stop the process at any given point in time and resume back from the previous state and continue to process new data. So with that, you can actually run streaming processing semantics every hour or every day. So when you combine these two very interesting things, I'm sure many of you guys have heard of or use a connector called autoloader, super popular on Databricks. It basically uses a streaming engine under the hood to continuously, or using a triggered mode, to ingest new files, new Parquet files as they land in cloud storage systems. Now, why do people want to do streaming? There are a few advantages of doing stream processing. Number one is it's super efficient because it only processes new data. It never reprocesses the data that has already been processed. Number two, it can achieve low latency. Well, it doesn't have to be low latency, but if you want to achieve for absolutely low latency for things like operational use cases, real-time workloads, streaming allows you to do that. And number three, it's fault tolerant because it keeps tracks of the checkpoint for what has been processed, and it has a state store, meaning it's super fault tolerant. You can shut down the stream processing for intentional reasons or during some error or crashes. You can bring it back up. It'll resume the process without having you to worry about where I left over last time. Well, then the question becomes all of these things sounds great. Why would I not do streaming? I should do streaming for everything. Why would I not do that? Well, because there are certain complexity, which I will explain a bit. One is development. So when it comes to streaming, events can come out of order. And because of the semantics of streaming, you process the data, then you write it out. You don't look back. So for handling out-of-order events, particularly if you do stream-to-stream joins, where you have two concurrent streams, they're moving at a different pace, things can get quite complicated to reason about the logic. Then the second aspect is with regards to like operational. So all the stream processing happens in state. The state can get fairly large. The data stream size might be varying. You have to figure out what's the cluster size and scale up and back down as the data volume changes. Many of the streaming workloads are spiky in nature. Then, when it comes to like non-happy case, something went wrong, you have to go back in time, fix some data, things get even more complex. I'll give you a simple example on sort of out of order. I think many of you guys probably already know. It's a very savvy audience. Hypothetically, I'm doing a simple calculation of the average temperatures that I collect from different sensors, and I want to aggregate by an hourly window. So in the case of streaming, let's say at the first hour, I receive these two rows, these two records. They're both temperature generated from the first hour, so it's super simple. I can just do the average. 24 plus 22 divided by 2, that's 23 degrees. Then let's say at the second hour, I receive this. So two of the records are generated from the second hour, but one of the records actually is like late arrival. I received the data at second hour, but actually the data was generated in the first hour. So it's easy to calculate the average for the second hour, but the question becomes, what do I do with this late arrival data? Because I've already calculated the first hour average and I've emitted results out. Now, in this case, you actually, you can't quite really say, I can add up 28 and 23 and do an average, because you also need the count information from the first hour, because you sort of don't know, the count of the data from the first hour that landed on 23. So in this case, for you to correct the result, you actually have to remember in your coding logic to store the count or some information from the first average in order to correct the results. So things get fairly complicated. Then what about batch? How is batch different? So batch different in a way that the semantics of batch processing is every time you run the process, you look at all the data that's currently available in the source. So the results of a batch query always reflect what's currently in the source and your current batch query. Now, in reality, people don't reprocess everything in the source. Typically, your batch boundary is some form of like a partition, like 1 day's worth of data, 1 hour worth of data. But as new data arriving in that partition, if you run the batch query, it reprocesses everything that's currently in the partition. So, same example, how would that look like if we do sort of batch semantics instead? Same thing, for the first hour I receive this, it's super straightforward, I calculate the average. And then in the second hour, 3 records getting added to it. So for batch semantics, when you run the query at the second hour, you actually have information about all the 5 records. So the average calculation becomes very simple. In the second hour, you'll just correct all the results. So as you program the processing logic, you don't need to think about like out of order, how do I store count and average information. You just simply write an average query and group by the hour. It'll just correct itself, right? So just to sum up a little bit some of the, the differences between stream and batch, these semantics, I think the pros of stream processing is that it's always efficient. It only processes new data. And for you to, for cases where you absolutely need low latency, streaming allows you to achieve that absolute low latency from minutes to even sub-second for real-time operational applications and use cases. But on the downside, you do have to be mindful of the complexities that's involved with stream processing. As you write your processing logic, you have to think about and consider for out of order how you correct the results. And that's where we have a concept called a watermark, which allows you to basically buffer the data for a certain period of time before you emit the results. But even with watermark, there could be like super late out of order arrival data. Then sometimes the data will just be dropped on the floor. So the results won't be 100% accurate. So that's sort of the trade-off with streaming. Then on the other side, for batch, as sort of we illustrate with this simple example, the processing logic is super simple. Like it's very easy to reason about, super simple for people to write a query about, and the results are always accurate. So whatever is currently in the data source, it's guaranteed that the processing output will reflect everything in the current source. But on the sort of downside, it's not as efficient as streaming because it involves some reprocessing. For the previous example, the first 2 rows were being reprocessed again, and it'll be slower than streaming. So you might be able to do minutes latency depending on the data size, but you're not going to do like seconds or sub-second. So these are sort of the semantic difference and some of the trade-offs. Then Enzyme, actually a quick show of hand. How many of you guys have heard of Enzyme? And okay. So this is a streaming audience. That's why you haven't heard of Enzyme, because Enzyme is the engine, incremental engine for batch semantics. So what does that mean is as a developer, as a user, you still write a batch query as if you're doing a group by of the average temperature, group by an hour. Enzyme is the incremental engine for the batch processing semantics. So behind the scenes, it'll figure out how to incrementally compute that query versus you define the logic yourself. So in the example that I just gave before, what Enzyme will do is that when it emits the first hour's average results, it'll actually also store the count and sum information in parallel. It's hidden from the query results so that you're not seeing that, so that when it receives the second batch of the records and realizes a late arrival, it'll use the previously stored count and sum information to update the previous results without recomputing every single records from the first sort of batch. So Enzyme is basically an incremental engine that powers batch processing semantics. So what that means is it alleviates one of the cons in batch processing, which is all the data will be reprocessed within the partition boundary that we've defined. It'll figure out how to incrementally processing the data whenever possible. So this is sort of a new comparison. Again, like Enzyme helps you sort of take advantage of the simplicity of the batch query, but at the same time, it'll try to make it efficient. So that you don't reprocess the data whenever it's possible. Now, this is how these things sort of manifest on the Databricks Data Intelligence platform if you are doing data processing, data engineering workloads. Under the hood, it's all running on top of the Apache Spark and Structured Streaming engines. So Structured Streaming is a streaming processing semantics engine. You can use that in continuous mode. You can use that in trigger mode. It powers a lot of connectors from autoloader to Kinesis, Kafka, PubSub, POSAR. Then we have Apache Spark, which is a batch processing semantics. When you do Spark.read, it reads everything from the source that we've defined. Now, on top of the Spark and Structured Streaming engine, we ship the product called Delta Live Tables, DLT. That's an abstraction that simplifies batch and stream processing on top of on Databricks. So when you use DLT, Flow is sort of the structured streaming concept, essentially a wrap-up of the structured streaming engine. When you use Flow, you can write into streaming tables, various syncs, like a Kafka topic and an OLTP database. That's when you're using the stream processing semantics. That's where you have to think about auto order, watermark, these type of concepts. Then on the other hand, we have materialized views, which is the concept for batch processing semantics. And under the hood, if you use materialized views in serverless, Enzyme engine will kick in. So you just write a simple batch query, the engine will take care of the incremental logic behind the scenes, so you don't need to think about it. Now, so these are sort of the two sides of what we call like fundamentally it's efficient incremental processing. On one hand, we have the streaming engine. You can achieve low latency, but you have to worry and think about the stream processing semantics. On the other hand, we have the Enzyme engine. It does incrementalization for you. It won't be as efficient as a streaming engine, but you get the simplicity of a batch query, but at the same time, it'll be more efficient than as if you to do the recompute of the partition yourself. Okay, so now we have these two things. We have streaming, which is stream processing semantics. We have Enzyme engine, does incremental computation for batch processing semantics. When should I use what? You have these two things. So obviously for people, for a handful of you guys who are doing these super low latency operational applications where you need super real time, then obviously you have to do streaming. So that's straightforward. But then for the middle ground, for a lot of you guys who are doing data engineering ETL pipeline, let's say I'm doing ingestion, transformation, my pipeline has an SLA of maybe minutes or dozens of minutes or maybe hourly SLA. Now I have these two things. When should I use what? Should I do streaming or should I do Enzyme with materialized views? So real simple, through sort of the medallion architecture, there are 3 layers. So these are some general recommendations based on all the patterns I've seen with our customers doing. So let's start with bronze. So the characteristics of the bronze layer is that it's typically ingestion workloads, right? Typically, it's stateless processing. You just grab data from the source with its cloud storage, with its message bus, and ingest the raw data as is into the bronze layer. And typically, these are fairly large volumes, so you cannot afford like reprocessing a bunch of these data. So at a bronze layer, streaming is almost always a better choice, because you don't get exposed to the complexity of streaming because it's stateless. You don't really care about out of order, and you just process a lot of data, raw data from the source. You cannot afford for recompute, and this is why sort of on the Databricks platform, connectors like autoloader, Kinesis, Kafka, these are super, super popular, used with a streaming engine to bring data from outside into the bronze layer. Then we have the silver layer. That's a bit more complicated. It's transformation. So many times it'll involve like lookups, aggregations, and joins. Then, the answer sort of depends. Like, if for your workloads, if you're using serverless, for your workloads, the Enzyme engine knows how to incrementally compute the results, you should go with materialized views because it just makes your life so much simpler in terms of how to write a query, how to operationalize a query, how to handle sort of non-happy path and scenarios. But if your pipeline has low latency requirements, you need to deliver the final results to the downstream analytics or dashboards within, let's say, a few minutes, then you can opt in for using streaming to do that type of processing. But be sure to be mindful of these streaming complexities up front. Then finally, we have the Go layer. So that's the last mile aggregation workloads. So typically, these are stateful operations, but typically the Go layer has a much smaller data size. And many times, the Go layer is owned by downstream analytics teams, not like you guys or the data teams, the platform teams. So typically, these folks' jobs are doing analytics, not handling like the complexity of data engineering, data pipelines. So I would say that most of the time, materialized views with Enzyme engine is a much better choice for the Go layer. It just avoids a lot of complexities with that efficiency. So that's what I have to say. I want to, get Indrajit on the stage to talk to you guys about the innovations we've been doing in these two incremental engines.
Thanks, Ray. So if there's one slide summary for the rest of the section of this talk, this is that summary. Okay. I see two attributes that we care about when we build a streaming engine or any engine that can do stream processing. One, how expressive it is, how powerful it is. And the second one is how easy it is to use it. Now, when I think of structured streaming, I think of something which is really powerful. You can use it to write any complex business logic, achieve whatever you can imagine. Okay. It's not for the faint of the heart. It's easy to use compared to many other systems, but not the easiest to use, of course. And then materialized views is on the right-hand side, something which is very simple to use. If you know SQL, if you can express your logic in a subset of SQL, we will incrementalize it for you. And that's the distinction between these two things. So as you do your own workloads, you try to figure out which one to use where. This is the slide probably which will help guide you. OK, a show of hands. It's summer, so it's probably time to do some vacations. How many of you actually enjoy the planning process of vacation? Those who really care about, show your hands, yes. Those who care about the planning process, they enjoy it. Not that many, OK. And how many of you just want to get to the destination and then enjoy, like have a beer? Lots of you. There are some who are in the middle. I don't know what you guys do. Maybe you guys plan for it, and then your spouses say, no, that's not what we're doing. Okay, that happens to me for sure. Okay, so I think of streaming as this, which is a sporty car. You can have manual transmission. If you are the person who cares about control, if you care about the journey, this is your vehicle. But if you want to go to the office, and you don't want to get into traffic, you don't care about driving, you don't want to be cursing others or get cursed, this is basically materialized views for you. You just express your destination, and you get there. And we do the heavy lifting for you. Let's put a little bit more concrete example here. So when I think of streaming, I think of a stream of data coming in. I may think of like breaking it up into hundreds of streams, writing to many downstream tables, thinking about maybe late arriving data, maybe even doing a site complex algorithm or summarization using a state store. That's streaming. And we provide all the constructs that are needed. You have watermarks, you have for each batch, you have state store, and so on. On the other hand, let's say you are writing this final, nice, jazzy little dashboard, and you want to just summarize data. You can simply write a create materialized view, select all data, do an aggregate. As long as the aggregation is supported by us, it's already incrementalized. That's it. You don't have to do anything on that. So what's new in structured streaming? So before I can tell you what's new in structured streaming, I need to recap what are the fundamental challenges in streaming? Because that's what we are trying to fix for you guys. I think there are top 5 issues in streaming that people have to think about. And Ray touched upon them. One is machines can fail. So you need to make sure that you get exactly one semantics. You don't want duplicates, right? Similarly, the second one is data might be coming out of order, and you need to handle it. The third one is, what do you do about your updates? There is some data which has been processed. Should you emit it, or should you not emit it? That's a difficult decision. Somebody needs to give you the API to help decide that. Then some of you want really low latency, and others want to write really complex business logic. So these are the 5 challenges we have been trying to address. And Spark Streaming has been the forefront in solving these issues. If you look at the last 3 years, that graph shows our usage has increased 3 times in 3 years. That's 3x, and these are millions of jobs running each week. The first 3 challenges that I talked about, exactly one semantics, the out-of-order events, and the update mode, these are existing features that we have made sure they're available to you guys from the last couple of years. So no changes there. You can use watermarks. You can use append mode. You can use your update mode. That's all great. What I've been focusing on is these last 2 things. One, low latency. And so now there's a new trigger called real-time mode, which you can use and actually achieve sub-second latency. And I'm going to talk more about it. The second one is state transformations. We recently launched a new API called Transform with State. I'm not going to go deep into it because today there is a session which goes into Transform with State. I would strongly encourage all of you to sign up for it. At a very high level, what's happening is we have automated a lot of things that were to be done manually. For example, handling triggers, timers, handling how state is cleaned up. All of that is pretty much automated with this new API. So if you are using state APIs, this is the talk that you should go to. It's there. Look at your calendar today. OK, let's talk about real-time mode. This is the one I'm really excited about. We have been hearing from clients on and on, hey, they want sub-second latency. There are banks who come to us, say they want to do fraud detection. It's millions of dollars per month, which is at stake. And urgency is the critical thing. And we're not talking about minutes. We're not talking about seconds. We're really talking about tens to hundreds of milliseconds. This is not everybody's use case, but this is a use case for some folks, which is but critical for them. So if you look at the place where workloads reside today, if you're at the latency spectrum, most of you are familiar with the right-hand side, which is Spark Streaming is really good at ingestion and ETL. And it does it like minutes, tens of minutes, and even like hours, depending on the workload. So it's really good at that setting. What we have been focusing on is now on the left-hand side, which is if you have an operational use case now, we can do it. You should try out real-time mode. It will give you sub-second latency, and not just sub-second latency, consistent sub-second latency. That's the critical part. That's harder to achieve. So what are the key ideas? Our team ended up doing lots of innovation here. I just want to give you intuition around 2 areas. One, you can think of it whenever we do batch processing. Whenever we took a batch of data, we want to process it, there's a fixed overhead associated with it. So it's obvious that when you try to do record-by-record processing, you want to really reduce that overhead. So that's one of the innovations we did. The second one is when a data comes in, any record that comes in, we want to make sure it doesn't wait at any stage, neither in an operator, nor in a pipeline stage. And for that, we had to do many changes. We have an enhanced scheduler. We have created a new streaming shuffle. And we had to actually change most of our operators. They are more streaming in nature. They are long-lived. They do not wait anymore. As a result, you can get to hundreds of milliseconds very easily. One of the big questions is, what's the programming model? Do you now need to learn something new? The answer is no. It's the same old API. The only thing you need to change is change the trigger. You just have to say real-time trigger, that's it. And then everything should just work. We are in private preview. So we are actually in public preview. So we are in gated public preview. And you can try it out for production as well today. So if you are interested, just talk to us or send us an email. Come talk to us after this session is over, and we'll be happy to help you out. But what's more is, open source is in our DNA. And you'll hear more about it in the coming sessions. We are going to open source real-time mode itself. We have interest from lots of contributors in the open source community who are interested in this feature, but also want to contribute to it. So therefore, we are open sourcing it. OK, I told a lot about streaming. I do want to tell you a little bit about materialized views as well. To appreciate what we do in materialized view, you need to think about what the problem really is. You end up writing an arbitrary SQL statement. You're just giving your intent. And somebody somehow is magically incrementalizing it. That's a really hard problem. That's a really hard database problem. Most of the products out there, external to Databricks, maybe solve a little piece of there. There are hardly any products, by the way. And those who do, they solve this much area in that space. We try to do a larger set of patterns that we can incrementalize. And our goal, our team's goal, has been, can we make it bigger and bigger in terms of the patterns that we can support, so that you can write any workload in this materialized view concept, and we incrementalize it for you. Here's an example, very simple example. You might be joining a customer data with an orders table, and what you want is maybe an aggregation or sum of total amount of customer sales. Your customer table might change, your orders table might change, but you don't do any logic around it. You're not handling anything. You just write the specification of the materialized view, and it is getting incrementally refreshed. That's the power of using materialized view. We already support a lot of constructs here. You can use group by, joins, unions, and many others. What we are now focusing on in enhancing that set of pattern which can be auto-incrementalized. For example, you can now write nested aggregates. You can add expectations. We have a new cost model which can figure out what is the right technique, which is the most efficient in incrementalizing this particular MV. We're also making changes to the UI. If you use the new Lakeflow UI, you'll start seeing suggestions which say, hey, maybe switch on your deletion vectors or row IDs, and this will automatically incrementalize the materialized view. Moreover, we also now have a standard cluster which can basically make sure that your TCO is lower. OK, this is all theory. Theory, everything works, right? So the good thing is, can we do a demo around it? And this might be the thing which helps you see how to use streaming as well as materialized view. I'm going to use an example which you can download directly from DB demos. So just after this meeting, if you want, you can try it out. Just install DB demos. You'll be able to see it. OK, let's see. Yes, you can record it. OK, yeah, so you can import this DB demos and try it out. The use case is about just analyzing a set of loans. So there are 3 different layers here. The first layer is the bronze layer, which basically includes the autoloader. I'll talk about it. The second layer is basically where we'll try to clean up our data, look at maybe expectations. And the final layer is the layer from which you can create a dashboard. We are using DLT for this use cases. You can use DLT. You can also use structured streaming directly for streaming tables. Either one is fine. Main goal is all of this is going to be real time. So whatever you're seeing is basically reading the data and then projecting. So there are 3 kinds of tables here. The first one is a loans table, which gets updated every few minutes. And then let's say the third one is a historical data, which gets updated every few weeks. The bronze layer, as I was saying, you can just use autoloader to create a streaming table. But before we do that, given that this is a set of queries, we'll just go to the DLT UI. It should show up right now. OK, yeah. We'll go to the DLT UI, and then we're going to just run this, because it's going to take some time to load and then populate all the tables. So once you have the DLT UI, you can just call start. That should just start the process. It will try to acquire resources, then it will do an analysis of the graph. While it does that, we can go and look at the actual tables, and I'll talk you through those tables. OK, so let's look at the bronze layer. So this layer, we'll use a streaming table. We need to use streaming, otherwise you will load all the data in one go. And our whole hope is that we are going to incrementally process the data, which is going to be cheaper. So the first table is a streaming table where you have transactions. So you just have to say, select from a stream. In this case, you just give the destination, the input location. The second one is a metadata table. I'll later show you the metadata columns and the values in there. We'll use it to enrich our tables. The third one is the historical transaction, which, remember, I told you it gets updated only once a week. Therefore, you can put a property saying that it should just trigger maybe once every 6 hours, because there is really no data before that. OK, before we do the silver layer, we can just go and see where the pipeline is. The pipeline is still running, so we can go back and look at the silver layer. In the silver layer, this is the cool thing. You can write expectations. Basically, you can put assertions on the data quality. The first one is a streaming table where we are going to do a join to enrich it. Here, we're going to add one column, which is the metadata column. I'm going to show you details of it later. And this one is called the accounting treatment column. So just watch out for that column when I show you the tables later on. The second one, the constraint, the expectation is really cool, because you can actually say that I want this table to have only data which has positive balance. So you can put data constraints. But more than that, you can actually quarantine your data. You can look at data which is bad data and put it in a table of its own. And here, this is the quarantine bad transactions table. Finally, you can create a materialized view, which can have this enriched but good data. OK, let's go and look at the UI. Everything has completed, so we can now dig deeper, drill down, and see how the data looks like. So here is one of those examples which has bad data. So this is the quarantine data. So you see balances. One of the balance columns should have less than equal to 0 value. On the other hand, the data that was good, the table where we had removed all the bad data, here all the balances are positive. And in fact, if you look at the last column, you'll see that there is an extra column which is called the accounting treatment. This has the data that we used to enrich. And here is the table which has the accounting treatment information. OK, so let's now look at the gold layer. Oh, actually, we can look at this materialized view also. This is pretty much same as the other tables. It is more enriched. It has lots of columns. I'm not going to go through all of them here, so you're just looking at a subset of these columns. Finally, let's look at the gold layer. This is the last set of tables which we are going to use to create our dashboards. So here's a materialized view where you can do aggregations. You can do unions. You can do joins if needed. We are not doing a join here, though. We can create aggregates which are based on the cost center. We can create aggregates which are based on the country. And we can now look at the materialized views which have these values. So if you go back to the UI, there are 2 materialized views over here which have these aggregates around the country. This one is the one with the country code. And you can see the 2 columns. What would be even more interesting is creating a dashboard, right? So we can just click on the dashboard from the same UI, click on Create Dashboard, go to the data source, and you can just type the name of the materialized view. So just copy the name, new loan balances by country, paste it in the UI. The UI will figure out the data set for you, and you can just load it. Finally, You can create a visualization, very easy, drag and drop, click on it, and we can use Assistant as well. So if you don't know what you're going to draw, you can just mention it. So here I'm going to say plot by country code, and you'll see I have a typo actually. I wrote county code, and Assistant still figures out this is actually country code and creates a visualization. Okay, that's it from the demo side. So hopefully this gives you a flavor of where you can use streaming and where you can use materialized views. All of these demos are available to you guys, so feel free to ask us questions. Ray and I are here.